Hi, everybody. In this lecture, I want to delve a little bit deeper into Chapter 5. There's a lot of very similar questions in Chapter 5, but they have some subtle differences. So that is what I want to focus on today. So I want to do a recap first. So for Chapter 5, there's sort of three main questions we've looked at. The first style question is when you know the x value, or if you're working with z values, you know the z-score. But the question is around finding the probability or the area. So for instance, your questions are things like, what is the probability of this happening? Or what is the area of this region in the picture, for instance? So here we know the x value or we know the z-score, we have to find the probability area. There's two main ways we can do that. We can use Excel. So if you're using Excel, the function we use there is norm.dist for normal distribution. You enter the x or z value, comma the mean, comma the standard deviation, and then the word true. And when you hit enter, it will give you the area or probability. Just remember that when we do this, the area is always going to spit out to the left of that z-score or x value. For the table, if you do have an x value, you would have to convert to a z-score first. And then you can do that using this formula here. And then you would find the value in your table. And then the table, again, will give you the area always to the left. So just keep in mind, if you're looking for the area to the right, for instance, you would have to subtract it with 1. Or if you're looking for the area in between two z-scores or in between two, x values, you'd have to subtract those areas together. The second main question we look at is if we know the area or probability, but you need to find the x value or the z-score, depending on what the question is asking. So here you know the area. I know the area is 5% or 0.324 or something like that, and we need to find the x value or the z-score. For Excel, the steps we're going to use there would be equal norm INV for inverse. You do the area to the left. So again, your area is always going to be on the left side here. Mean and standard deviation. And you press enter, and then your x value or z-score will be returned. Just remember for z-scores, the mean is going to be 0 and standard deviation is 1. For x values, you would just use whatever mean and standard deviation was provided in the example. And then for table 4, again, keep in mind you're always looking for the area to the left in the table, to the left of the z-score, for instance. And here, you're going to look in the middle of the table to find the area and work your way back outwards to the z-scores. Once you have the z-score, you will then have to change to an x value using the following formula, again, assuming that you don't want just the z-score answer, you want the actual x value answer. And then the last thing we considered was section 5.4. And in this case, we have, we're sampling, but it's not just one single person we're considering. So we typically do multiple samples, for instance, or we do a sample of not just one person, but multiple people. So the idea is that you have not just one thing, but many things that you're sampling from. So in that case, we're going to use what's called the central limit theorem. You do need to make sure a couple things hold. Either your sample size is at least 30 or your population is normal. And once you have that, everything else that you've already done is sort of the same, but the difference is the standard deviation you're going to use is the original standard deviation of the population, but divided by the square root of n. So again, subtle changes here where you're not just selecting a single person or item, but we're doing multiple. So again, more than one person, maybe 100 people or 20 people or something like that. Now, on the next page, you have some examples, and I do strongly encourage you to pause the video here and try them on your own first. So you have examples of all three types here. We're going to use the same background information for all of them. So it's about the overhead reach distance of adult females. The mean there is 205.5 centimeters, and the standard deviation is 8.6 centimeters. Overhead reach are typically normally distributed, and this is based on data from the Federal Aviation Administration. The overhead reach distances are used in planning assembly workstations. So for instance, think about how far you can reach above your head. That's what they're talking about here. If we build workstations or even like airplanes or desks where the top is too high and most people can't reach it, then it's not going to be very helpful for us. So we use overhead reaches here to help us design workstations or help us design airplanes and things like that. All right, so I'm going to do some of these with a table and I'll do some with Excel. But again, I do encourage you to kind of pause the video here and see if you can do some of them on your own. So we're going to find the probability that an adult female has an overhead reach greater than 212 centimeters. So look at here, we're looking for a probability. So if you go to the page before, we're of the first type here. So find the probability. This is mainly sections 5.1 to 5.2, by the way. All right, so for me, I like to draw a little quick picture first. My center here is at 205.5. So remember, your mean is right at your center. And then for this particular example, we're looking for a reach greater than 212. Now, 212 is bigger than 205. So it's somewhere on the right over here. So we're looking at, this area over here. Now, I know the X value there is 212 because they give that to me. So what I'm looking for is the area. So I want this area, which is the same thing as the probability. All right, so I'm going to go to my table here first. And I actually just have the textbook out, so you can look in the appendix in the back of your textbook, and you have your normal distribution table there. I'm going to notice that my value here is going to be, it's a positive 212. It's to the right of our mean, so I'm going to end up using a positive z-score. The thing I have to do first, though, if I'm using the table, is my table only has z values in it, not x values. So if I'm using the table, I do have to change to a z-score first. So I'm going to start by plugging in the x value, which is 212. I'm going to go ahead and subtract the mean, and then when I do that, I'm going to divide by my standard deviation, which in this particular case happens to be 8.6. And then I'm just going to take my calculator out and go through that. So I have 212 minus 205.5. Do that part first, divided by 8.6, and I get about 0.76 if I round to 2 decimal places there. So this is going to be the value that I'm looking at in the table, right? So if I'm using the tables, I have to go ahead and use z-scores. My z-score is positive, so I'm going to go on the positive table. And I'm looking here for 0.76. So on the left side, I see 0.7, and then I have the 6, which is over here. And then I'm going to see where those two meet up. So I'm just going to go across and then up and see where those meet, and I get right here 0.7764. So that's the value that I'm going to use. All right, now just be careful. The table and also Excel, if you're doing it on Excel, always gives you the area to the left. So they're not giving us the area on the right side, they're actually giving us this side for the area. So if you need the area on the right, then what we're going to have to do is subtract with 1. So I'm going to do 1 minus 0.7764. And I get about 0.2236. So my probability that someone or a female has an overhead reach greater than 212 centimeters is only about 0.2236, so about 22% there. This makes sense to me because, again, the average is only 205.5. So the average is much lower, 212 is higher, and I'm not shading in that much of the graph. So 0.2236 seems reasonable here. All right, next one. Again, same kind of question. So we're doing the same style here. Find the probability. We're going from 205.5 as my center, and we're going between 212 and 220. So in this case, we're starting at 212, and we're going to maybe 220 here. Again, just doing a quick graph, just kind of for my own purposes to see what's going on. So I'm trading in between two values. Now, again, if I'm using the table, I'm going to have to go to z-scores first. So, x equals 212. We already have, we did it in the last one, and we got a z-score of 0.76. And we already saw that that probability was 0.7764. So we have that first piece done. Now, for the other one, I am going to have to do some work out here. So for 220, I'm going to do x minus the mean over standard deviation. So 220 minus 205.5 all over the 8.6. Make sure you subtract the top first. You're going to get 14.5. And then when I divide by 8.6 and I round, I get about 1.69 there. So again, just doing it right on my calculator here and then rounding as needed. Z-scores, we most often round to 2 decimal places, although there's a couple exceptions. And now I'm going to go ahead and find this value in my table. Again, it's positive 1.69. All right, so here's the 1.6. And then the 9 in this side of the table is way over here. So I'm going all the way to the right. I get 0.9545. So 9545. Now, because you're going in between two scores, what you're going to do is subtract these. So I take that 9545, I take that 7764. I'm going to go ahead and subtract them. And again, I'm just going to use my calculator. And I have about 0.1781. And again, this seems reasonable. If I look at my values here, I don't have that much shading. It's actually smaller than the one before it, right, which actually kept going. So 0.1781 seems reasonable. It's less than my first answer. It's not that much shaded in. So this seems accurate. So remember, whether you're using the table or Excel, if your shading is on the right, you're going to have to take the probability and subtract it with 1 at the end. And if your shading is in between, you're going to have to subtract your 2 probabilities to get the answer. The only time we don't have to subtract is when the area is already on the left. And that brings us to this next example. All right, so our mean here is 205.5 again. This time we're going less than 185 centimeters. So 185 is on the left here. And I want values less than. Now we can go ahead and do the same process. I want to mix it up though for those of you who like Excel. So for Excel here, I'm going to use the normal distribution function. I'm going to give it the 185 first. I'm going to tell Excel my mean and my standard deviation. And then I'm going to go ahead and use the word true there, which gives me a cumulative value, which is what I want. And again, you do have this function on the other page as a reminder of what you should be plugging in. So let me go to my Excel. I'm going to just bring up a new sheet. There we go. And I'm just going to use it as a big calculator here. So I'm going to do normal.dist. So I'm going to use the first one. There's different versions. So again, I prefer not the S or anything else. Use the first one, the normal.dist. My X value is 185. My mean is 205.5. My standard deviation is 8.6. I'm just putting commas in between. And then you can write or just click that word true. I close my parentheses and then I hit enter, and there is our value. So we get about 0.0086 rounding to 2 decimal places. All right, so norm distribution, 185 is my value, the mean, standard deviation next, and then true. And if I go back to my paper here, that is our final answer. So when you're finding values where the area is always on the left, you don't have to do anything else. So don't, subtract here. Just use the value given. So this is just my final answer. The only time we have to subtract when we're finding this type of question is when the area is on the right or in between. If the areas are on the left, then you can just use the answer. Now, the nice thing about Excel is that it bypasses having to go to a z-score first. So that is why Excel can be a little bit faster here. You don't have to do the z-score part first. We do need that for the table because our table is only in z-scores. I don't have x value tables. So for Excel, you don't need to worry with the z-score. You can go right in with the information given. And then again, because our area is on the left, we would just take the answer as it is. This seems reasonable. This actually would be a very small spot. 185 is 20 units about lower than the mean. Over here, we were going only about 7 units higher, and our probability was already pretty small. So, 20 units away is pretty far away. So we're not getting a very high probability for this one here. All right, the next one is a little bit different. So for number 4, we're finding the overhead reach of an adult female that marks the 90th percentile. So as a side note, percentile is always the area to the left. So if I draw my picture here, again, we're still doing the same center, same kind of data. We want 90% on the left. So 90% of my data is on the left. So I'm basically shading in a lot here. And we're looking for this value, basically. So what is the mark that sort of shows that boundary point of the 90th percentile? Now, this is a different kind of question. So notice here, I know the area this time, but I don't know the x value. Whereas in the last examples, I knew the x value, but not the area. So this style question is similar to this second case here. So this is mainly section 5.3, although there may be some other questions mixed in, but this idea comes into play in 5.3. So we know the area and we're trying to find the x value. All right, so what we have to do if you're using the table that you need to do first for the table is you'd have to find the z-score. So in your table, you always need the area to the left, which here is 0.95. Now your table is typically out of 4 decimal places. So I could attach 2 zeros here, and then I'm going to look for 0.9500 in my table. Now there's 2 sides of the table. One side has smaller values in the middle. The other side has larger. So I'm going to go to the side that has larger values here. And I'm literally going to try to find 9500. And it's like a puzzle. So we're just kind of searching through. And we can see that we're right here. I have 9495 and 9505. Now, neither of these is perfect. If you have one that's perfect, then there you go. If you have one that is closer, then you just choose the closer one. Here we happen to be right in between, exactly, right? They're both kind of 5 10,000ths apart here. So this is one of those exceptions where we tend to use 3 decimal places. So because we're right in between 164 and 165, we'll average those 2 together. So again, here's one of those weird exceptions where because we're perfectly halfway in between, so we're halfway between, I'm just going to use BT for between 1.64 and 1.65. And if you average those together, you get 1.645 for your z-score there. Now, because you're using the table, again, they give you a z-score answer, but you don't want that. You want the x value answer. So what you're going to do is take the mean, and then you're going to add it with the z-score times the standard deviation. So our mean here is 205.5. Our z-score was 1.645, and our standard deviation is 8.6. And again, we're just going to use our calculator. Just watch your order of operations. I would do the multiplication first. So 1.645 times 8.6. And then I'm going to add that to the 205.5 here. And what I get is about 219. I'm just going to round to 1 decimal place and kind of be consistent with all the others, 0.6 centimeters. There we go. So that would be my actual cutoff, the 219, again, which makes sense. 219 is above 205.5. It should be significantly above, because we're doing the 95th percentile, so you don't have that much shading to the right. And that would be my final answer. For the next one, we have a similar style question. Here, 5% of the population lies above that mark. All right, so if 5% is above, so this area here is 5%. Now, remember, everything that we do for tables in Excel, they don't do area on the right, they only do it on the left. So if you have 5% on the right, you must have 95% on the left. So this is another way actually to say the same question we just had, right? Here we had it as a 95th percentile. Here we're saying 5% on the right. They really are the same boundary point. I'm going to do this with an Excel. And for Excel, we're going to use norm.inverse. Now, you do always give the area to the left. So you don't give the 5%, you give whatever's on the left side. So the left side is 0.95. I give it the mean. And then the standard deviation. So let's go to Excel. So I'm going to use norm inverse here. My area to the left is 0.95. My mean is 205.5, and then my standard deviation is 8.6. And when I hit enter there, I do get that the X value is about 219.6, which is actually the same answer I had in the previous problem, right? So I did my norm inverse, area to the left, the mean, and the standard deviation. So again, we get the same answer. The benefit of Excel is that you can avoid having to go to z-scores first. Now, sometimes you may want the z-score, which is fine, but you can see the Excel is just a little bit faster because I can get the answer right away and I don't have to go to the z-score. Just be careful with the areas. Remember, everything is always area to the left when we're doing the computation part, so you may have to do some tweaking. Here, you have to find the other side sometimes to plug in, but otherwise it's pretty straightforward. I'm going to stop this video here and we'll take, you can take a break if you want or you don't need to, and then we'll go to the last three questions. The last three questions are actually going to be this part here, which is section 5.4. So it's going to be similar to what we just did, but a little bit different, some minor changes.